This section will demonstrate the SeeStack training software that we have, training tool, that will help introduce the concept of stack effect of a building and also ventilation, things that affect the ventilation rate of a building. As you can see, there's a neutral level of the building here, and that's the point at which half of the holes in the house, half of the leakage is above that neutral level and half of the holes or leakage in the building is below that level. And you can see there's also a visual cue with the blue lines that show there's no pressure at the neutral level, and it gradually gets bigger as you go towards the bottom, gradually gets bigger as you go towards the top. The numbers will get higher. The things that affect the stack effect of the building are the stack effect pressures is the temperature difference between inside and outside, and the distance from the neutral level. That's what will affect the stack effect pressures of a building at the top and the bottom. The total ventilation rate is affected not only by stack effect but also by the tightness of the building, whether mechanical fans, whether the mechanical effect of a building, whether the net mechanical effect is air moving out of the building or air moving in. It certainly affects the ventilation rate of the building, and wind will affect the ventilation rate, although that's not accounted for in this simulation software, and the distance or the location of the neutral level will somewhat affect the ventilation rate of the building. So we'll see how all of these things interact. So the things that are adjustable are the height of the building, the CFM 50 of the building we can adjust, whether we have a net negative or positive ventilation or exhaust or supply mechanical ventilation in the building, and the location of the neutral pressure plane we can adjust, and the indoor and outdoor temperature. So those are some of the things we can adjust in the software, and as we adjust those, what will be affected is the pressure at the top of the building, pressure at the bottom of the building, the neutral level may move, the total ventilation rate and the added ventilation rate may change. And remember, our CFM in always must equal our CFM out. So we'll see how all of these things interact. So let's start by adjusting the height of the building. So our default is a 2-story. If we go down to a 1-story, we see that our pressures get lower and our ventilation rate gets lower as the building gets lower. So we'll go back to 2. Our ventilation rate goes up, our pressure goes up. If we go to 3, our ventilation rate goes up, and our stack pressures go up. Next, we'll turn the exhaust fans on and off, and we'll see that that as we increase the exhaust rate up and down, our neutral level will go up and down, and our pressures at the top and bottom will go up or down. The neutral level is also adjustable. As we move the neutral level up, our pressure at the top of the building goes down because our neutral distance from the neutral pressure plane is less, so our pressure will be less. As our distance from the neutral level increases, then our pressure increases. So this neutral level high is a home that has a lot of attic bypasses, and if we seal those attic bypasses and when most of the leaks were up, we may have a really low neutral level, which increases our pressure at the top and decreases our pressure at the bottom. So we'll go back to that neutral level, and we'll see that as we increase temperatures, we see our pressure at the top and bottom go down, and actually if we get no pressure difference between inside and outside, we've got no stack effect. as our pressures go down, our temperature goes down, our pressures at the top of the and bottom of the building increase. And as we go above, when it's warmer outside, we'll have a reverse stack effect where pressure is leaking out. The heavier air is falling and leaking out to the bottom of the building, and air is being replaced because our CFM in has to always equal our CFM out. So now as we turn exhaust fans on, we'll notice that our neutral pressure plane actually goes up, and let's go up to about an 80 CFM fan. And one thing you'll notice is that when we've got an 80 CFM exhaust fan running, the amount of added ventilation rate is only about half of that, and the other half is coming in was air that was naturally coming into the house already, and now that air that was coming into the house is going out through the exhaust fan. So we didn't we only added about 43 CFM of ventilation, and so our neutral pressure plane goes up because now instead of some of that air that was exhausting out of the building, instead of going out naturally, it's going out through the fan. So that raises our neutral level, in the building. Next, I'm going to show. This is a 5-minute baseline period that was taken during a big building test, and this was an 11-story building. It was actually 8 stories on the front, and it had a sloping grade, and the grade dropped 3 stories over the length of the building. And we measured pressures at the bottom of the building on all 4 sides. So we've got 4 pressures at the bottom of the building and 4 pressures at the top of the building. So up on the roof, we're measuring the 4 sides of the building also. And you can see it's kind of hard to see our numbers here, but this is -20. So our pressures at the bottom of the building were around -20 pascals, and our pressures at the top were about between 2 and 5 pascals. So you can see we have a very high neutral pressure plane on this building. Our pressures are lower at the top because our distance from the neutral level, here's our neutral level, 0. Our distance from the neutral level was high, so we had a lot of leakage at the top of the building here, not so much down lower. One other interesting thing is these 2 lower pressures were going out at the very bottom of the building, through the lower part of the building, and these other 2 were going out what was actually the 3rd floor up. It was grade at the front of the building, but it was 3 stories up. So we can see as we're moving up the building, our pressures are getting lower, and then as we get above the neutral level, our pressures go positive. So that's so what we can take from this is that if we want to measure the pressures in the building, we need to run our tubing out at that level. Pressures are going to be highest at the very bottom. If we want to measure that stack effect pressure, we have to run our tube out at the bottom. If we ran our tube out at the bottom and went all the way up to the top of the building with a long length of, we've got 100 feet of hose, we go up to the top of that building, put our gauge up there, we're still going to be reading -23 down here, even though our gauge is up at the top of the building, because the weight of the air in the hose is equal to the weight of the air outside the hose, and our pressure doesn't change. Measuring pressure is dependent on where the probe exits the building. In this section, we'll do a brief introduction to our TEC Trainer. If you would like more detailed information about the TEC Trainer, you can go to our website or our YouTube channel and view the previous webinar on the TEC Trainer that's specific to the TEC Trainer. So what's included in the TEC Trainer is a hard shell case That includes the frame and the hardware for assembling the frame. And then there's a soft shell accessory case that contains everything else included in the trainer. And in that accessory case, there's the red enclosure, red nylon enclosure covering. There's 3 leak adjustment windows, so you can adjust leakage from the enclosure to the outside. And there's a white attachment plate that will Velcro onto the side. There is a flex duct section for doing duct testing that will Velcro to the inside of the trainer. There's a tubing kit that includes all the tubing required to do the testing, blower door duct blaster testing using the trainer. We include ring C for the blower door because some of the testing is at lower flows where you'll need ring C if you don't already have one. There's a extra gauge hanger bar so you can attach both your blower door and duct blaster controller and DG700 gauge to the frame during testing. So the first step in setting up the trainer is to the L-shaped piece of iron that make up the frame of aluminum that make up the frame are hinged at the corners using shoulder bolts. So you'll unfold those sections and lay them out on the floor. And as you can see, there's labels A, B, C, and D, and there are stickers on each section showing which part is which. And the A sections are, there's 2 A sections and 2 C sections, and they're interchangeable. So A will work on the top right and lower left corner, C will work on the top right and lower left corner. So then you'll assemble those sections, put those sections together, and then connect the 2 sections, front and back, together. And the front section will form a door jamb in which you can install the blower door into. Next step is you'll put the red nylon enclosure covering over the frame and attach the stabilizing feet to the outside bottoms, and then stretch the Velcro over the frame and Velcro it to the front section of the frame. And a nice part about that is that will help hold your blower door frame in place, so you don't have to worry about it popping out. It overlaps just enough to add a little more security so your blower door frame won't pop out. And then you'll attach the leakage adjustment windows on the side. They'll Velcro on the side, and then you can pull that plastic window open or close to adjust the air leakage. Next, you'll attach the, if you're doing a duct test, you'll attach the flex duct inside the red nylon panel. Open the zippered opening, attach the that ductwork in there. There is those of you who have duct blasters will recognize this is a section of the flex duct that goes with the duct blaster, and it has that tubing array on one end of it that has the T connection, and you'll connect a short blue hose from that T connection up to this this blue bulkhead up here that has a tubing connection on the inside and the outside, and you'll connect it to the inside and then attach an additional tube to the outside going to your gauge. And for the duct test leakage setup, next you'll attach that Velcro of the white attachment plate and line up the hole and Velcro that to the side, and you'll attach the square transition piece of your flex duct to that white attachment plate, and then you'll attach the flex duct to that. So now we've got a blower door and a duct blaster with the duct going through the center of it. So here's a little clearer view of where we're running that blue hose. We're attaching that to the flex duct, and we'll attach that on the side away from the attachment, so our pressures are more stable on on the right side here, and then we've got a leakage adjustment window to adjust our leakage to the outside. You can see there is a 1 inch by 3 inch hole. That's our leakage to the inside. So we'll have both a leakage to the inside and a leakage to outside with that flex duct. So besides doing a total duct leakage test, duct leakage outside, and blower door test, we're able to demonstrate those things in front of a classroom, and also give your students some time to set up, get some practice setting up and using the equipment. You can also demonstrate the use of other products, such as the exhaust fan flow meter or the flow blaster. The weight attachment plate is sized such that you can use it to measure flows, to demonstrate the use of the flow blaster or the exhaust fan flow meter. Just remember, the exhaust fan flow meter is only designed for air going into the fan, measuring exhaust or return flows, and not for measuring supply flows. Another option is if you have multiple trainers, you can connect them together. Just leave the feet, the stabilizing feet on the two outside trainers, and remove them from the intersections, and just the double-sided Velcro window will connect the two trainers together at the window, and that works really well. They stay pretty stable just using that Velcro as the attachment to connect the trainers together, and that allows you to do some town home guarded testing. What a guarded test is, one way you can test these is just test them one unit at a time, and then if you have all three running at the same time, that's referred to as guarded testing, where you have each unit at the same pressure, and because there's no pressure difference across the units, there's no airflow through the holes adjoining the units. So you can demonstrate that concept, or you could introduce some zone pressure diagnostic concepts, where, say, the middle unit is the house, and the one on the right is a garage, and the one on the left is maybe an attic section, and you can do some zone pressure diagnostic demonstrations using the trainer. It is also designed so you can set up a 3-fan system in a trainer and do some big building demonstrations, or demonstrate the TEC 2 software, where you can control all of the fans using one slide bar. It's also helpful to use our DG700 simulator, which is a free download from our website, and that will allow you to project the gauge on the screen, or 2 gauges on the screen, and run a test from your computer screen.